Fluid mechanics. We will first introduce the concept of density, which is defined as mass over volume. Because we are talking about mass, sometimes this quantity is referred as mass density. Although perhaps being one of the most popular densities, we can drop the word mass, and when we say density, we understand we are talking about mass density. And this mass density is a property of the material. In other words, if we have a cube made of aluminum and we have another cube made of aluminum, obviously a bigger one, they will have the same density because they are made they are both made of aluminum. So this is cube 1 made of aluminum, this is cube 2 made of aluminum. The density of cube 1 is equal to the density of cube 2, but of course the masses and the volumes are going to be different. So mass density, or in short density, is equal to the mass divided by volume. If you are wondering, well, are there any other densities that we encountered in physics before or in the future? Yes. Anything that is divided by a length or by an area or by a volume is going to be a density. In electrostatics, if I have a wire which is charged with charge Q, then we define the linear density as the charge divided by the length of the wire. So charge over length is charge density, linear in this case. If we have a sheet of charge of area A, we define the charge density as charge over area. If we have a sphere of volume V charged with charge Q, then we say the density is charge over volume, the volume density. In electromagnetism, so this is all about charges, these examples that I showed here, but also in electromagnetism, we know that light is a combination of electric and magnetic fields that propagate. So each of these fields carry an energy. So for example, the electric field carries an energy over volume of epsilon naught E squared over 2. It's not actually expression that matters right now, but the fact that we have an energy density. We have something similar for a magnetic field. It's going to be P squared over 2 mu naught, and so on. You got the idea. Anything divided by a length or by an area or by a volume is called density. Going back to our mass density, I already introduced the symbol rho. So when I say again density is a mass over volume, the symbols we are using is the Greek letter rho, that some students like to call it P, but it is in fact the Greek letter rho, is equal to the mass divided by volume. And when it comes to the units, remember the shadow equation behind any equation that we encounter. So the SI unit is kilogram per cubic meter. Of course, other units are acceptable. Any unit of mass over any unit of volume will do the job. A very popular unit is gram per centimeter